So the content for today, we're going to review 3 new designs for the Fidelity Open Bridge Rack. So for those who might not be familiar with the design, the original design, Fidelity participated in the hackathon 2 years ago and submitted the design for a convertible rack that was compatible with both EIA and OCP hardware. Since that original hackathon, we worked with Electrorack manufacturer to develop the first open bridge rack, which was convertible between EIA and OCP. We contributed that design last year when it was accepted in late December. And we're really excited today to hear that there's 3 new manufacturers in the mix offering their spin on the open bridge rack design. So without further delay, I'm going to turn it over to Denny with Belden, and he's going to represent the Belden design.
All right, thank you. My pleasure to be here. My name is again Denny Blouin. I'm a mechanical engineer by design. I'm a product line manager with Belden, and specifically in charge of everything related to infrastructure management within enterprise networking and also data center. Okay, so yesterday I was talking with Steve here. Okay, and I've asked him, like, Steve, tell me, like, what about why 21-inch mount racks? And he told me, oh, you know what? Because we wanted to mount 3 of the Intel motherboard width-wise, so it forced us to come, you know, with the design expanding from 19-inch to 21-inch. So yesterday in my hotel room, I started to search the web, and I found this picture there of what is supposed to be one of the first relay rack dating from 1911, I think. And a guy there, probably a smart guy, decided that he needed to populate a rack with 1, 2, 3, 4 wide, not motherboard, but probably some type of electromechanical relay. And that's what drove probably the 19-inch standard, okay? So again, the standard 1934, the last revision was in 2005, and I don't know of another standard in the industry that I've seen so little change between the original version of the MD latest update, okay? But again, as you know, the standard defines, mounting hole position for equipment and, distance between rail, left to right distance. And the interesting thing in that is obviously in EIA, there is no definition of the depth of the rack or of the width of the rack. And that's a big, big difference between the EIA standard and the OCP standard, where the distance between the front and rear support is very critical in terms of meeting with the power bus bar in the back. Okay, so create some little constraint there. Okay, this enclosure there, as you see, is quite look a lot like this one. This was one of our colo customer. Okay, having about 600 of those per data hall. So when I read about the Fidelity work, where the notion of having customer, colo enterprise grade data center, having a need to convert existing enclosure, or having a need to make sure that whatever enclosure they're going to buy today is going to be fully compatible with an OCP standard down the line, was something of real interest to us. Again, because our customer are faced with that. Okay. The other thing I wanted to mention is when our customer are buying enclosure from Belden, they are expecting these enclosure to withstand between 3 and 4 generation of active gear. Okay, so if you think of 3 years per generation in a normal enterprise data center, so they want to make sure that the investment is going to be made for 9 to 12 years. So these things are pretty expensive, and changing racks is very disruptive in terms of operation in a data center. So again, a need for a rack that can be converted, and also a rack that can be retroverted back to EIA. So if it's a colo customer, maybe I've got law firm ABC renting these 5 and law firm B, and in 3 years down the line, another guy will come in and he's going to want EIA to be reinstalled in. So being able to convert from one to the other and back to EIA was in our mind. Okay. The other thing which our customer, again, are expressing a lot of interest in, okay, is the notion of access to the computer computing gear. So when dealing with, finance, credit card related, healthcare, defense related, government agency, to these folks, the notion of a fully open rack with no protection to the gear is a big no-no, okay? So I was a bit surprised that in the standard OCP rack, there's no provision, for a potential addition of a front and rear door. Although nothing in the design would prevent doing that, okay? But obviously in some industry, this is a very important request, okay? So the notion of security. The other one here is we see a lot of different, well, most data center enterprise grade or co-location grade nowadays wants to, again, deploy in the most efficient way. And we see out there various ways to manage, the hot air. So having a rack system that's compatible with various, airflow management approach and various cooling approach. And there you're seeing like a chimney approach. And this is one we just did in Texas, where they're using a rear door, a cooling rear door, are things where we see, a standard rack playing a role there, a standard rack which is fully compatible with OCP in making sure that we can adapt. And what really refreshed me when I came here was the notion of, the next step in open compute, it being a much broader acceptance of the OCP principle. So it's clear by having, a set of infrastructure and the rack themselves being able to adapt to existing site is we think a big plus. So that's why we decided to jump in and contribute with this product. By the way, just a online chimney approach, and it's clear that in more performing IT gears with very high delta T, okay, servicing the equipment from the rear is becoming a big issue. One of the key reasons why Open Compute have designed a rack that's only serviced from the front, okay? The approach with these racks is when I open the rear door, I'm pumping, air at 130, 135 degrees Fahrenheit, and the chimney system will start, pulling air through, creating some type of bypass, but at least making the IT technician work there, feasible, not having him to, go through like a limited schedule to access the aisle and stuff like that. That's why we think, that's why I see a lot of our customer, going with chimney style containment to cope with the very high exhaust air temperature. Okay. The other thing I wanted to mention is, like on this one, you see the front door is red. Okay. Like everything else, sometimes one size does not fit all. And in data centers, either the space constraint, either customer best practices or customer request makes the idea of having customizable rack being OCP compliant a nice proposition. Okay. So the rack you see there. It's an open bridge rack, so it was built, from the contribution that Fidelity have made last year. And this rack is fully compliant with both EIA standard and OCP standard. The dimension of this one here are 28 by 48 inch by 89 inch tall. So there is two versions of this one rack there, the tall one, which is this one here with 40 OU. And there is the shorter version of it, which Brian helped me, I think it is 36 RU. OU.
That one's 44 OU, shorter.
Yeah, okay, 40 OU, okay, in the 84 inch package. Okay. Again, this one fully convert, you can convert this rack from OCP and back to EIA as needed. Right now, we think one off conversion will be of about 40 minutes, okay? It's clear that conversion of multiple racks, let's say I've got 30 of them to convert, and I have a team of workers with the right tool. Our goal is to lower that, below 30 minutes. Okay, so that's what we're shooting for. we've got like thousands of rack already installed using this exact build there. So in terms of the structure of the rack, okay, this rack is capable of 1,000 kilogram dynamic load and 1,350 kilogram of static load, all right? In the case of the open bridge rack, the assumption that for a lot of customers, the rack are going to be on site and they're going to bring IT gears to populate inside the rack is quite plausible also. So having a rack with that range of capacity, does make sense. And yeah, again, this is where we are with the standard frame design here. Okay. You know what? In the telecom standard, now the 23-inch mount have been existing for quite some time. So the notion like telco and central office have been using, wider mounting spacing. So the notion of using either a flippable rail or some type of adjustable device inside a wider rack to cope with various width, there's nothing new there. And that's been proven and that's been used in our industry for years. So the notion of using it, to convert from 21-inch mount OCP to 19-inch mount is even less of a challenge because the moment is lesser. Okay, we've got a lesser of an adjustment to make. All right. And you're going to come here and see the rack after. Okay, but so the first thing is you've got to dismantle the rack, turn the rack 190 degrees apart to use the OCP face rack, and then comes a set of accessories. So we've got the rear assembly for the stop channel in OCP, all right, and then we've got the front cable management panel. So it's clear that when converting one of those racks from EIA to OCP, some accessories need to be added to the assembly, all right. So the first version of this rack we have built was using like the corner post shape in contact with the cable management panel to position the front rail, and then we was using the rear post of the rack in conjunction with the length of the stopper panel to position the rear rail. Okay, so what we've learned doing that is the fact that these racks in EIA format do not require the same tolerances to ensure front to rail position, okay? And, in order to be able to build a rack like this in a cost-effective way using standard, build practices, okay? What we came about was, let's use the EIA principle, which is the rail are fully adjustable and are floating inside this enclosure. And let's build precise jigs, so positioning jigs to ensure that when we do conversion to OCP, we perfectly control the distance between the front and rear rail and then ensure that the OCP dimension in terms of mating with the busway are going to be perfectly matched every time, okay? So we did it. We had a couple racks that were meeting it and then a couple racks that were not meeting the requirement. And again, we realized that, again, the tolerance in binding a corner post that's 89-inch long and the type of parallelism we need between the front and rear rail were very difficult to meet, counting on, on surface touching each other to align everything, okay? So this is what this thing was about there. We've got like the key dimensions on 789 millimeter, okay, from the front server or shelf positioning, and then to our rear blocker there, and again making sure that we have a perfect meeting with the rear busway. Okay, so that's where we spend a lot of our time. And when I pushed this enclosure here earlier, I forgot my little jig in the other room, so I'll go get the thing after. Okay, but that's the idea here. All right. So a couple of these jigs would be available in the data center, and whenever they need to convert, they're going to need to bring the jig just to make sure that everything is perfectly aligned. By the way, the jig does more than just positioning. It's also, we've got one top and one bottom jig, so to ensure that the rail are perfectly parallel one to the other. Okay. The other big thing, the other biggest difference in EIA, the equipment itself, because it is bolted to the rack and to the rail, the equipment itself gives structure to the whole assembly. Where in OCP, because we've got IT gear floating inside, L-shaped rail, we don't have that type of structure that's induced by the equipment that's hosted inside the rack. So these are important notions there for these racks. So again, that's what this rack is about. Where we spend a lot of time was, again, making sure that if I've got 100 rack like this on my floor, and tomorrow I need to convert 80 of them to OCP, that the 80 would conform and be usable, okay, and not having to spend 3 hours trying to adjust everything and having the move needed to be aligned with March for everything to work, okay, that was very key here, all right? So thank you very much. Again, after, if you want to kick tires on the product itself, and if you have any questions, please go ahead.
So
Yeah.
the fact that you mentioned the structural integrity that is added by equipment that is sandwiched inside the 19-inch rack.
Yeah.
What is the difference you're trying to say with, since you're putting in an adapter, does that lessen the structural integrity, or does it make it less rigid, or what's the
No, you know what? Again, the positioning jig is only there when we do the conversion, and it's just to make sure again that the front to rear dimension are perfectly respected, and that the parallelism of the rail themselves is where it needs to be.
Okay, so it's not any less stable.
Absolutely not.
Oh,
okay, and this jig is removed, so there's a couple of them. There would be a couple of them in the data center. And these jigs would be like, again, it's a positioning tool that could be reused again and again. All right.
Thank you, Danny.
All right.
Next up, we're going to have Delta present their open bridge rack design.
Okay, while the laptop setup, maybe I can introduce myself. This is Anthony from Delta Taiwan, the mechanical guys here for Rick always. And I appreciate the Brian and the Steve over this opportunity, so we can maybe take about 20 minutes to sharing what Delta have the contribution for the OCP in the lesson. I stay in HDMI. I don't think so. HDMI
There you go. It's on the other one though. It's on that string. They've got it on that screen. We just need to. Well,
Okay.
we did.
He knows what button to push. It's on fixes yesterday.
Only.
Oh, there it is.
Okay. There you go. Yeah, we got it. Cool. You should be here earlier.
We can get you on the, there you go. Yeah. Thank you.
Okay. The first stuff we have done in the last year, mainly that will be the Facebook version, the V2 version of OpenRec. Okay, and the key feature for the V2, that will be the couple things. First one, yes, this rack is fully complies with the Facebook V2 and the OCP spec. And second thing, this rack is capable for the 1,250 kilogram loading. And third, that will be the 2 power shelf and power zone. Before that, that will be 3. And the last one, the customer spec allow this rack to freeze the free configuration ability. This is some mandated, we call the spacing configuration. But actually, as I have mentioned, due to nowadays, sorry. Okay, due to the switch tray or the fixing structure and the bus bar have been extended. And so now in the V2 rack, like everything, simply we can say the switch can be anywhere inside the rack. And totally that will be the 39U in the V2 version. And this page shows some major components that will be installed inside the OpenRec for V2. And you can see that will be the ACPBU and the DCPBU. But that's different thing from the V1 is the PBU is on the top of the rack and allow the unfilled replaceable ability. And second thing is the power shelf. Currently, that will be the 2 versions of the power shelf available. And it's still mounted on the central of the top room or the lower room. And following that will be most important thing is how does Delta make sure the rack works? In the design stage, yes, absolutely some simulation or some calculation is absolutely needed. But for Delta, we still believe the testing is most important or solid thing. So that will be the 4 criteria or the 4 areas the testing we have done for the V2. That will be the tester, swivel level of field, and the rack devices. Last one is moving. From design point, we select or define the tester we use. Each one should be able to support or load it for 550. That's considering some tolerance and safety factor and for the total rack weight. And we, based on this condition, have conducted 2 component label tests, the static and the dynamic. This is we take the picture on the static load. We take it, actually we load it for the 600, almost 660 and for 16 hours. Next thing is we also test the rack in the dynamic. That will be the 2 cameras taken on the testing equipment. One is outside and one is on the center of this rolling table. And the setting condition is based on the international standard. We set the 550 kilogram loading, and the total moving distance will be the 2.7 kilometer. Then we have set out the speed, also the obstacle height, the 3.6 millimeter. Even more, we must during the test, we change the moving direction to clockwise or counterclockwise, each 3 millimeter. The total test is about an hour. Next new stuff is the level fit. While the rack is really installed on data center, the level fit is mandated force or withstand the old rack weight. So we set up more higher the safety factor for the level fit. We set up the design criteria will be the 1,200 kilogram. But that's also for the vertical and the angle direction. And in the real test, we highlight the testing requirement to almost be the 1,600 and also 16 out. That's in vertical. And in the angle condition, we're trying to set a same requirement, but only differently. We're using one picture to make this field bend as the 10 degree. And also we test this in a two direction to make sure the fit is always work. Now we're trying to do some the devices, the install test. We have tried a lot of the stuff, almost all the stuff we know might install into the V2 rack. And that will be including some copy nuts and also the AC, different types of AC PDU and DC PDU and some power shelf. Even more, that will be including the rack mount devices. And here is some picture we have tested and for the rack. That's a DC PDU, AC PDU plate type. They are gone now, but yes, we also try the plate type and the box type. That's the power shelf and the PDU. That's the real side. Last thing, I would like to say that will be the most tough thing will be the rack moving. That's really difficult thing. After we have certified or qualified the caster and level fit, then our challenge will be the rack mainframe is strong enough to support so many stuff at the weight. So we have tested a couple items. First one, that will be over the 6 millimeter high obstacle for fine ties, and 1 inch gap, and also the rack for the 10 feet, 5 degree. And also that will be some we call the qualification to make sure the moving force is as low as possible. That's some picture we during the test. But please note, due to the fully loaded rack is such heavier. So in fact, at the beginning we try to using the manpower to move it, but failed. So we must using the lab to build to lead in the rack moving on the surface. Now on the flat surface, no problem. But if we want it move close to the 6 millimeter high obstacle or the 1 inch wide gap, that would be the problem. So that's another testing. We build up some specified RAM and using the lab to put the rack up and down. And yes, thank you, Hasha's help. Last thing that will be we're trying to move in the rack in the perfect or ideal, the typical the flow. And okay, as the test result, that will be the needed force only be 2.5% of the total weight. That's under the customer's request, the 5%. Let's start, we have designed for the customer is the PDU. The PDU I have mentioned now is not on the rack sideway, it's on the top. And this make the PDU can be on field, replace serviceable. Another thing is, due to we always keep the PDU in the same form factor, that means for different regions power requirement, we can build any PDU you want. Let's take one example of the current PDU that will be for 277 volt and 16 amp, 2 input, 2 output, and that's a locking latch. That will be the DC PDU. In the V2 generation, the DC PDU, the input is from these 2 long straight cable. So simply we can say the PDU, DC PDU power up by the power share, then provide some needed the devices for the 48 volt DC. And almost basic, that will be a 2-in or 2 share, and then provide a couple set of the output connector. Also have the signal like the V1 version style. This is the model list we have nowadays for the PDU. We have 5 different versions AC PDU and 1 version DC. And that contains several different criteria or the function like the surge protection or the different input plug and different input quantity or output quantity. That's based on any, you can store the configuration. Next thing, yes, we have also do the modalities, the open bridge rate improvement. The key feature that almost said, as you know, that will be available for the OCP and the EIA, the transforming. Also, that will be the easy and quick conversion. That thing is lock and removable, the front and rear door. That thing, that will be the, yes, 2 different two independent power rod in OCP or OCP config. That's the some typical external physical dimension. This is done. Okay, this page on the right side, left side for you. That will be the OCP, the spacing arrangement. We have the 16 OU above and the 16 OU below, and the 2 power share in the middle. Due to the customer request, that will be the truly the 2 power share and 2 power zone and the 2 N plus N power system for the highest reliability. And yes, it can be converted to the EIA standard. That will be the standard EIA 19-inch and 42U. Next item is, okay, this front door and the rear door in Delta's design can be removed tooless. So simply, you can say, you can the front door and rear door will be optional. This page will show you the how can we transfer or transferring the EIA to OCP. That will be mainly different, will be this 4 vertical pin. And that will be simply 5 steps for the transforming. And yeah. This is some physical sample picture on the sample review. That will be EIA version. that we call a removable door. Then following, we also provide our customer by this unique or the very special the power system. That will be the 2 power shelf and 2 set of the bus bar, also including the 2 special PDU to make everything can only power up by 2 plugs. That's a real angle view. Yes, you can see the bus bar and the 2 power shelf, and this 2 is the PDU. Let's start from detail about the PDU. PDU itself is pretty simple, just the plug input, but that will be power up the 2 power shelf on left side or right side. And something special is we also offer the two set AC outlet so that you can power any devices need AC power. This is another version because customer need a Europe market. That almost sensing just change the plug and the working voltage. Then we are introducing the power shelf. The power shelf that will be the 2 versions for the fidelity. Well, first one that will be for the North American market. That will be the 208 3-phase 4-wire. And the other one, absolutely, that will be the wide wiring and the 346 to 415. And both shelves can support a maximum 600 amp. That's N plus N redundant. This is a simple, we call a block diagram for the delta wiring, the power shelf. We have the 3-phase input on one side and the other side. So that will be totally independent 2 groups of the power shelf and 2 power supplies. And each power supply that will be the 2.6 kilowatt. So totally that will be a 7.5. This is some detailed front view of the power shelf and the rear view. That will be the one we call the RMC slope, and that will be the 3 slope for power supply group 1 and group 2. On the rear view, yes, 2 independent input and the 2 set output bus bar. Additionally, we have the 2 protection breaker for the input. That's another block diagram for the wire wiring. And almost sensing, only different in the input, we have the neutral here. Almost same from, but on rear end, we change the input connector from 4 to 5. So that will be allow the 5 wiring system. Also, it can avoid the customer to make the wrong connection. That will be the more detailed, some power supply that will install on that power shelf. We call the model name here, the DPST 2430. Actually, we are trying to upgrade the power rating. That's the key, the specification we have nowadays. That's the voltage, almost 2500 watts. And we can upgrade to the 3000. The OCP or the power density number here. This is some mainly we call a PSU, the block diagram. As Delta or the expert of the power system or power supply, we always offer the best or the high efficiency power supply. for the input AC, the 230 volt, the efficiency almost the 95, less than maybe the 94.6 or 7 in 50% load. The last thing, yes, we have done is the RMC. The simply, you can say the RMC is the one controller or maybe the information corrector for all our power system that can provide you to your any laptop or the control system via the Ethernet. To make the RMC be more flexible, we're trying to do the modularized design on the RMC. So internally, the RMC, that will be the two main board. One is for we call the SMP board. The other one maybe the interface board. So based on different power system or different customer requirement, we can just simply modify this interface board and keep the SMP as the standard one. That's some physical sample we have. The interface board and the SMP. This is some typical graphic we can show from, maybe we say that will be the Delta standard graphic interface. But yes, it also can be the modified or customized. You can see the input voltage on the AC or DC, and the output voltage, current, and the total power, also the temperatures. So you can monitor everything about the power system. Even more, I think this is even load. So whenever the AC power, input power is brown out or interrupt or drop, everything will be recorded in the even load. And so your system controller or operator can simply get is clearly know what happened. After so many things, maybe we would like to emphasize one thing is for Delta, okay, yes, we are the power expert. But now maybe we can also provide you the rack, PDU, and RMC. So from the buying point, the Delta should be the one-stop shop for all this hardware. And also, we always focus on the OEM, ODMs, customer, and business. So any customized, always welcome. Any question? Okay, thanks.
That's great. Thank you very much. You can do the laptop.
All right, check, make sure it's working.
Yeah, let me see if we have.
There you go. Hang on. Well, maybe.
So next up is Stack Velocity, and they'll be presenting their version of the Open Bridge Rack as well.
All right, Russ Lindsay for Stack Velocity. So I don't know, those of you who don't know who we are, we're a business unit of Jabil. Jabil is a large contract manufacturing company. Basically, we always joke around that we're the largest company that we've ever heard of. We make various electronic parts for a lot of different companies, and as well as a lot of plastic parts, a lot of those things of that nature. And Stack Velocity is a business unit specifically dedicated to cloud hardware. So we deal with basically, we take the approach of a hardware agnostic vendor. So we work with partners worldwide to be able to come up with basically any solution that fits what our customers need best. So essentially what we did is spent about 6-8 months ago, we started talking with Fidelity about the bridge rack and the stuff that has been done in the past, and how there was a need for some diversification in the market and being able to get some additional vendors to be able to supply this rack. So one, to help drive market awareness, two, to help availability, and three, really just to create a little friendly competition and get everybody kind of on an even playing field for being able to sell these things. So what we did is we set out to basically try to come up with a way to maybe meet somewhere in the middle between a standard rack and an OCP rack, with using a lot of the same standard rack functionality and techniques that are still out there today, and being able to support both functions of EIA and OCP. So essentially what we ended up doing was, rather than going with a full welded frame design, we ended up with a flat pack design. So that's going to help us be able to import them into the U.S. In a less expensive way. Also, able to speed things up in some cases and be able to ship larger quantities in smaller containers. The second thing that is really of interest in this particular rack is something that we kind of came across the customer who was asking some questions about how to be able to utilize something like this in a co-location facility. And they said, well, we want to be able to support either option of OCP or EIA racks, depending on what our customers might want to use. And so basically, we sat down and started talking through it and trying to figure out, okay, well, obviously, having everything consistent in your data center is an important thing. Everybody wants to look nice. And so the bridge rack is a good option to pitch for that. And so then they came back and they said, well, but we want to be able to separate the rack into multiple zones for different customers, depending on what you might want to do with it. You might have one customer who only needs half a rack worth of space. And so we said, oh, well, okay, so let's stop and think about this for a little bit. So we ended up offering basically this configuration where we're able to use a split door and separate the rack into 2 zones. So each one is independently keyed. So with the 2 separate power shelves, one on top, one on bottom, they're totally self-contained, so nobody has to worry about the second vendor getting in and messing around with the other, the second customer getting in and messing around with the first customer's gear. And so that really, it's something that they're still looking at right now. We haven't finalized anything yet, but I think it's a really good solution for them. And a couple of other things we're talking about, actually adding features to this, is to be able to add some locking mechanisms in so that the power shelves can't be accessed at all. So you can't pull power supplies, or just things to be able to make it where it can be maybe in a little bit more open facility rather than somebody's dedicated facility and still function well. You guys have kind of seen several different racks today, so we follow the same specs, so we have a lot of the same features everybody else does, right? We've got the panels that are interchangeable on the top, different configurations, knockouts for additional holes for cabling, cable access drops in the front and the back. It's convertible within. I I haven't done it myself, so I can't promise, but you know, it's in that 45-minute range, which is something that we feel like we need to work on. This is our first sample that we got back for prototype, so we're using this as an opportunity for us to take feedback from people and see what changes that they might like in a route, and also ourselves to be able to go back and say, okay, how do we improve this? How do we make it work better for everybody? So that, in my opinion, that function should happen in about 15 minutes. I don't think that I think if you're taking longer than that, you're probably wasting time, and it might be easier to do something else. But so I think that's going to be kind of the goal that we're going to push for on that part. As far as other special features, we included the side panels in this so that you guys can kind of take a look. Again, it's an adaptation of a standard rack where we're able to use a locking side panel that can be easily removed without having to unscrew anything, or it's just you basically have a key lock, you take it off, you can access anything you need to from the side cabling perspective or what have you, and then just slap it back on. So again, we also did the two different sizes, the 40 OU and the 44 OU. So they're basically essentially the exact same rack other than the height differences, depending on what co-location you might want to put it in, or if you've got overhead buses that you have to be able to clear. We brought the short one just because we figured that a lot of people would be showing the taller one, but we want to be able to have people do a comparison side by side and see, okay, well, oh wow, so it actually is quite a bit shorter, and it fits some, these are tall, but it fits through doors. So this is essentially just all the exploded view of the entire rack. So we've got all the internal components, which were basically the stuff that was spec'd out of the original contribution to the community, and then we've got the additional parts, which are the outside of the rack, which I have another view of. So yeah, this one. So this slide basically shows the side panels and the doors, which I don't have the second door in here. But each of the top panels are interchangeable. They're exactly the same size. So depending on what configuration you need to do, you can move those from one position to another, or you can use them all solid. Somebody had some crazy request about being able to stand on top of it, and so we made sure that it didn't fall in when somebody sat on it. And then I think Brian, did you guys come up with an answer on these? The cutouts? Are you guys going to
On the grommets on the side?
Mm-hmm.
Yeah, we feel the need to create an opportunity for people to be able to cable between racks, but that particular position worked well for EIA. It doesn't work so well for OCP. So we were looking at what Facebook was doing at the top of the rack as a potential solution as well. So that's an area of opportunity for us right now.
Okay. Good to know. I was just curious if you guys had any.
I think we're going to eliminate that component in our requirement set. So
great. I think we're at the end. So I blew through it kind of quick because we were running out of time. But if anybody's got any questions, we'd like to speak up.
I've got one. So I like the split zone concept. I hadn't seen that yet. Do you guys do you plan to split the rails so that someone could do a half OCP, half EIA? I've gotten several questions regarding that feature this week.
Yeah, so that's something that I've been kicking around, and actually there's a lot of opportunity there as well. I think that's something that we should definitely be able to offer. I think in this particular configuration, especially, it's imperative that you be able to offer it that way. And some of the other things that we were looking at is there's a couple of other vendors that have emerged who are selling power shelves now. So there's other options like the used to be Power One, Bell Power now. They've got a power shelf that's 18 kW that's half the height of the standard one. So with that, you gain back a little bit of switch space. You really only gain half the server's height, so you can't put another server in, but it does give you an extra switch location if you need it. And it also ends up with two specific with two power shelves, you end up with the max of 36 kW in a single rack. So in short, I think that there's going to be a lot of innovation around that power structure as things go forward. and as people start to realize all the things they can do with it. Virtual power systems, I don't know if you guys are familiar with them, they're doing some other cool stuff with that, with the in-rack battery systems where they can actually peak load off of the batteries themselves. So if you end up in a situation where you need to spike power, they can draw that in. So there's a lot of innovation going on right now, and I'm really curious probably over the next 6 months to see how that all shakes out, but it's pretty cool.
Yeah, we agree on our side. We're pretty happy to see sort of the disaggregation of power from the rack, and seeing like a lot of the innovation happen in both spaces. So.
Anybody else?
Might be unrelated, just for all the manufacturers. I haven't heard anybody. I think it is unrelated because it's not specific to the spec as it is now.
Mhm.
Has there been any talk about bringing in stuff for data center information management, like the RFID sensors inside the rack, and also seismic platforms for places like this where we install in data centers and got to put it on the platform to stabilize it?
So I haven't specifically heard of that being added to the foundation spec. I've heard of a couple of people who are doing some things in that space and some new products that might be coming out, but I don't have any specific examples I can share.
We are at Fidelity. We're working on an environmental monitoring system right now, so to gain more visibility into sort of the white space within the data hall. So we are working on a sensor system, but we don't want to incorporate it into the rack specification. It'll be sort of a standalone system.
Yeah, I figured it would be adjacent to.
Yeah.
But and I did hear in the Fidelity presentation the other day some open sensor or something, or is that?
We have a program called NextRack,
Okay.
and so what we're developing is one of the components or features of that NextRack generation is environmental monitoring. So
Okay.
I'm expecting that we'll likely contribute what we put together once
Great.
we've completed that effort.
Thank you.
Thank you very much, guys.
Yeah, thanks everybody.
So, well, thank you for everybody. So that's the end of the engineering workshops for this week. We do ask that everybody make their way into the main hall for the closing. I think that begins at 2:30 p.m. today. So thank you all very much for your participation, and we look forward to future meetups.